Hello everyone, welcome to physics classes. I am Sarabdeep Kaur Sidhu here. So in the previous lecture we have studied about the permittive unit cell, non-permittive unit cell. Clear ji? Now in this lecture we will study about Bravais lattices. Clear ji? So Bravais lattices are of two-dimensional they are of 5 types, and in three-dimensional they are of 14 types. Clear ji? And a lattice, we know that a space lattice is a array of points, and every point has identical surrounding. So that lattice is a Bravais lattice in which every lattice point have identical surrounding and obey symmetry operations. So on the basis of these, in two-dimensional, so we discuss the Bravais lattice in two-dimension and in three-dimension. So first of all, Bravais lattices in two-dimension. Clear? In two-dimensional, the Bravais lattice is of 5 types. That is, first, this is an array of points, and the unit cell is of like this. So this lattice in which atoms are at the corners, but the primitive translation vectors a, b, in two-dimensional we take only 2. Clear? A, b, or also it is also called axis length primitives a, b, or when we take it vectors we put here vectors, translational vectors also. So a, b that are here in this first, a, b is not equal. If this is a, this is b, then in this a is not equal to b, but this angle gamma, that is equal to 90 degree. Clear ji? So this type of lattice is called permittive. First is permittive lattice and also called permittive rectangular lattice. Permittive first lattice, permittive rectangular lattice. Clear ji? Permittive rectangular lattice in which a is equal to b, a is not equal to b, and gamma is equal to 90 degree. Clear ji? So this is first lattice, Bravais lattice. Then this is second. In this, atoms are at the lattice points, also at the corners, but also at the center. So this is not permittive, but it is centered rectangular lattice. It is centered rectangular lattice. And in this is a, this is b. A is not equal to b, but gamma is also equal to 90 degree. Only difference between these two is only this is primitive, because atoms, or we can say points, are only at the corners, but in this also at the center. Clear? See? So we discussed 2. Then is third. This is third. In this, a, this is like square, so a, b, and in this a is equal to b, and this angle gamma, this is equal to 90 degree. So this is square. Lattice. Or we can say square Bravais lattice. Clear? And this is, in this, a is not equal to b, gamma is not equal to 90 degree, or this is oblique. This is oblique lattice. Clear? And in this, a is equal to b, but gamma is equal to this angle is equal to 120. So this is hexagonal. Lattice, Bravais lattice. So in two-dimensional there are 5 types. What are these 5 types? I am repeating again. First is permittive rectangular. Second is centered rectangular. In this, a is not equal to b, gamma is equal to 90 degree. And in this, a is also not equal to b, but gamma is equal to 90 degree. Here gamma is interfacial angles. We have studied in the previous lecture about interfacial angles and primitive translational vectors. and in this A is equal to B and angle gamma is equal to 90 degree, and in this A is equal to B but gamma is equal to 120 hexagonal, and oblique A is not equal to B and gamma is also not equal to 90 degree. Then is the Bravais lattices in 3-dimensional. In 3-dimension, on the basis of difference in the axis length and interfacial angle, the crystal system first is of 7 types, then is subdivided into 14 types. Clear? So there are 14 Bravais lattices in 3-dimension, 5 in 2 and 14 in 3-dimension. Okay, ji? So we discuss one by one. We will discuss. So first is cubic. First is cubic. So in the cubic crystal system, next this subdivided into 3 types. That are number of lattices in this case is 3. And what are 3 types? Symbols P, I, F. P stands for primitive or simple. P stands for primitive or simple when atoms are only at the corners. Only at the corners. So this is primitive. That's why we called it primitive or simple. ठीक है जी? And second is I. I means body centered. When atoms are at the corners and also at the body of a cube. When I put here on atom. So this is body centered cubic system. Then third is face centered cubic system. In face centered cubic system, each atom at the face of a cube. So there are 6 atoms at the 6 faces. 1, 2, 3, 4. One is backside, one is either. 2 are here. So 6 atoms. 1, 2, 3, 4, 5, 6. Okay. So this is face centered cubic system. Clear? And what about axis length and interfacial angles? In a cubic system, interfacial angles 3, alpha, beta and gamma, they are equal, and 3 are 90 degree, mutually perpendicular axis. Clear? And A is equal to B. This is A, B, C, axis length or primitives or lattice parameters. They are equal in 3 sides, A, B and C. Clear? This is cubic system. Then is tetragonal. Tetragonal. In tetragonal, A is equal to B but not equal to C. Means alpha. What is this? Means axis length, that 2 are equal but not equal to third. And angles, their axes are mutually perpendicular. 3 angles, interfacial angles, alpha, beta and gamma, they are equal to 90 degree in this case. And what about the types of lattices? A number of lattices here is 2, and types is symbols P and I. P is primitive. Atoms, this like this. Atoms are only at the corners. This is this. And I stands for body when one atom is at the body. So 2 types of Bravais lattices in the case of tetragonal. Clear? And third is orthorhombic. Orthorhombic. This is in orthorhombic. Axis length A is not equal to B is not equal to C, but 3 angles are 90 degree. 3 angles are 90 degree, but A is not equal to B is not equal to C, and there are 4 types of lattices, 4 types of Bravais lattices. What are the 4 types? One is primitive, atoms are only at the corners. Second is I, that is body centered. At the body also there is an atom and also at the corners. Face also at the corners but also at the faces. And C is base centered. The atoms are at the corners and at the bases. Clear? So this is about orthorhombic. Clear? Like this, if we consider this, so orthorhombic, but we consider here A is not equal to B is not equal to C. Then in base centered, one atoms at the corners and also at the bases. One is here and opposite is one is at here. So this is orthorhombic. Clear? 4 types of Bravais lattice in this case. Then is the monoclinic. In monoclinic, A is not equal to B is not equal to C. Axis length. Clear? 3 are not equal. And 2 angles are equal and interfacial angle and equal to 90 degree, but third angle is not equal to 90 degree in this case. Then there are two types of lattices, P and C. P means primitive, that is simple, atoms are only at the corners, and C stands for base centered, atoms at the corners and also along with corners also at the bases. Clear ji? Then there is triclinic, fifth crystal system, that is triclinic. In triclinic, the axis length of the unit cell A is not equal to B is not equal to C, and but interfacial angles alpha is not equal to beta is not equal to gamma is not equal to 90 degree. Clear ji? And only one Bravais lattice, and only one, and that is primitive. Primitive means atoms are only, or lattice points are only at the corners. Clear ji? Then is trigonal. Trigonal. In trigonal, A is equal to B is equal to C. Clear? Axis length 3. They are equal, and alpha is equal to 3 angles. They are equal but not equal to 90 degree. 3 are equal but not equal to 90 degree. And this is also a primitive. Only one Bravais lattice, and that is primitive, means atoms are only at the corners. Clear ji? Then is hexagonal, last hexagonal. So in hexagonal, A is equal to B. This is also hexagonal type. A is equal to B is not equal to C. Alpha, 2 angles are 90. Third angle is 120. Third angle is 120, and this is also of only one type, that is primitive Bravais lattices. So when we add these 3 to 5, 5 plus 4 9, 9 plus 2 11, 11 plus 1 12, 13 and 14. So total Bravais lattices in 3-dimensional are 14, and in 2-dimensional they are 5. So this is all about the Bravais lattices in 2 dimension and in 3 dimension. Thank you.